Okay, class, this is the second video for disk tools. So, in the last video, I showed you how to create a traditional Linux partition. The only problem with that type of partition is whatever size you created, that's the size it is. If you need to resize it later, your only option is to delete it and recreate it with the new size. So, a company called Sistina, which no longer exists, developed something called LVM, which is Logical Volume Manager. And basically, it allows you to dynamically resize your partitions whenever you want. So, I'm going to show you how to set up that LVM partition. Sistina was bought out by Red Hat, so Red Hat now controls this project, but a lot of distros use LVM. So, what we're going to do is look at PV display first. PV display shows you the volumes that have been added to the LVM system. Right now, Red Hat, when you do the install, they create an LVM volume and add that second disk as if the second partition on the first disk as if it were its own physical disk. Um, so right now we have one partition or device, I should say, that's part of this LVM. So we can do VG display. So PV display displayed physical volumes. VG display shows volume groups. So once you create, you add your physical disk to the LVM system, then you can create volume groups from those physical disks. And basically, what you're doing is creating logical um, disk from those physical disks. Now, these logical disks aren't going to be constrained by the physical disk. So if you have three physical disks of 100 gigs each, this will create, you can create a volume group that will be 300 gigs. So you're not limited to the physical size of the volumes. So if you needed a 300 gigabyte disk, you could take three disks and join them together to make one logical disk called a volume group that'll be 300 gigs big. And lastly is LV display, which is the partitions essentially that we create from that volume group. So first you add your physical disk to LVM. Then from those physical disks, you can create any volume group that you want, any size you want that's not limited to the physical disk. So if you wanted to add three 100 gig disks, you can make a volume group that is 300 gigs. So kind of think of this as, I want to say like a virtual disk, that really is being made up of three physical disks. Then once you have that volume group set up, you can then create partitions, and they're called logical volumes, on that volume group. So what we're going to do is we have two unused disks, each 20 gigs. The reason why they're so small is because of the limitation of ACE IT Lab. So we're going to do, guys, if you don't remember the commands, you can do like PV tab, and it'll show you all the commands for physical volumes. So what we want to do is PV create, and we're going to add dev, VDC, and VDD. VDC, and dev VDD. So we're going to add those two physical disks to this LVM process. So now LVM controls them, not the real machine. So from that, we're going to create a volume group. And again, I can type VG tab tab and see all the commands that start with VG. So what we want to do is a VG create. And we're going to create a 40 gig. Actually, I'm just going to make a 30 gig because it might round it down. It might not be a full 40 gigs. A 30 gig disk, and I'm going to call it VG underscore public, and I'll explain the naming convention here in a little bit. And I'm going to use these two physical volumes to create that disk 1. Sorry, I'm jumping the gun. I'm going to create a volume group called VG public, and we're going to use these two disks. So now I'm going to do volume group display. There's mine that I just created. And here's the one created during the installation. So the system kind of sees this as a disk now that's 30 gigs big. And from that, we can create logical volumes or partitions essentially. So I'm going to do LV to create it. Remember, PV if you're dealing with physical volumes, VG if you're dealing with volume groups, LV if you're dealing with logical volumes. You add your physical volumes to create volume groups. The volume group is like a new disk. Then from that new disk, you create logical volumes in that, which is essentially partitions. So I'm going to make it 30 gigs in this volume group. I have 39.99 gigs available. The name will be LV public, and the volume group that I'm going to create the partition on will be VG public. This is the name I'm going to give. I forgot a dash here. This is the name I'm going to give this logical volume. And I'm going to get the space from this volume group that I created earlier. This volume group has 39.99 gigs available. I'll be using 30 of them. Hit enter. So here's my naming convention. This is going to be my mount point. And this is kind of my naming convention. So I'm going to do list. And it made a device driver for this. So the naming convention is going to be the volume group separated by a hyphen with the logical volume. So the device we just created, this partition that we just created that we need to format is list dev mapper volume group before we were dealing with VDB1. That was our partition. In logical volumes, this is going to be our partition. So we put two physical disks together. We created from those two disks that were each 20 gigs, we created a 40 gig volume group. In that 40 gig volume group, we created a logical volume that was 30 gigs. And that's it. I like to put underscores here because the separator is a hyphen. I don't want to have to keep referring back to this name. So if I have a naming convention and I remember what my naming convention is, I can kind of figure out what the device driver is actually going to be. So now that we have that created, we need to format it. So what we're going to do, just like when we formatted this, we can format this the same way. Because our system now sees this as just a regular partition that we can format just like any other partition. But this partition, I can resize. This one I can't. So I'm going to do MKFS, XFS, and I'm going to point to my device driver, mapper, and there just formatted that partition. If I want to give it a label, I could do XFS admin. The label I want to give it with an uppercase L is dev pub, no, mount public. That's going to be my mount point. And the device driver is dev mapper vg underscore public hyphen lv underscore public. Now I gave it a label. If I want to view the label, I can do a lowercase l and then my device driver. If I wanted to test mount it, I first need to make the mount point. I'm going to create a folder under mount called public. Then I'm going to do mount dash t xfs. The device driver will be dev mapper vg. I'm hitting the tab key. I'm going to mount it to mmt public. df-h to see it. There it is down at the bottom. Or I can do mount and I'm going to just grep for public. And there it's mounted. So if I want to mount it at boot, I go into SCFS tab. I'm going to expand this so it doesn't do the word wrap. I'm going to hit colon to go into command mode, R bang, block ID, dev mapper vg underscore public, because I know my naming convention, hyphen vg underscore public. I want the UID and the value, not the equal sign and all that. Again, this is the command that I'm doing right now. Anyone can access this, and it's just a tip. So you make your life a little easier. If you can memorize that UUID, more power to you. So there's my UUID. Now I'm going to put UUID in front of it. I'm going to put my mount point, the file system type. I'm going to mount it with the defaults. I'm not going to check it or tune it. :WQ to save and exit. I'm going to umount MMT public. Now I'm going to test mount it again, but I'm going to not supply all the information. All I'm going to do is give the mount point, which will force the mount command to read FS tab to find out the missing information. If it successfully mounts it, that means it was able to read FS tab and I didn't have any typos. Okay, guys, the only thing left that I need to do in these 3 chapters are, oh no, actually I want to show you one other thing. The whole benefit of doing this is so you can resize it. I want to show you how to resize a partition. Guys, this is the same process applies to Windows or to Linux. When you resize a partition, you then have to resize the file system. Just like if you take a disk and you partition it halfway, if you expand that partition, you still have to expand the file system, meaning the NTFS or FAT32 or whatever it is. But with Linux, we can do it all in one step. We can resize the partition and resize the file system at the same time. So right now, I can see that this is 30 gigs. And I know when I go into VG display and VG public, I can see that I have 39 gigs available to me. So I'm going to resize this to 35 gigs, this partition, because my volume group still has space available to me. Now listen, if I ran out of physical space, I can add more hard disks to the machine, add more physical I could add the physical volumes, then associate those physical volumes with this volume group. Then at that point, I'd have more disk space to work with, which you can't do with traditional Linux partitions. So I'm going to do LV resize. The new size will be 35 gigs. I could make it smaller if I wanted. I'm going to hit R. That lowercase r means not just resize the partition, but also resize the file system, which is XFS. And I'm going to specify my device name. So it just automatically resized. That's the benefit of using LVM, is given the ability to resize. So now I'm going to do df-h, and I can now see it is 35 gigs. I can do mount grep public, and it's still mounted. So without even having to unmount it or take the system down, on the fly I can just resize the partition. If you run out of disk space, add more disk, associate the disk to LVM, associate those disks then to that volume group, then whatever volume group that logical volume was created from, and at that point you can just resize the logical volume however you want. Okay, that's it for this video. The next video, which will be the last in the series of 3, I'm going to show you how to find files on the operating system using either find or locate. So that's it for this video. Thank you.